So in this video, I'll be reviewing the questions from the last um, slide, ionic bonding. So, what's the best description of the ionic bonding? A would be metallic bonding because it's electrostatic attraction between positive ions, or you could also call it cations, and delocalized electrons. um, but it's where they're asking for ionic bonding, which is D, and it's an electrostatic attraction between oppositely charged ions. So it would be electrostatic attraction between cations and anions. Second question: what's the formula for the compound formed by aluminium and sulfur? So aluminium is in the third group, and it's a metal, so it would lose those three electrons, while sulfur is in the second group. I mean the sixth group, so it would gain two electrons. And when you write the formula, it would be uh, D, Al2S3. So, what happens when lithium reacts with bromine? So, lithium is a metal and bromine is a non-metal, and they form an ionic compound. And lithium is in the first group. It's a first group element, so it would lose one electron to get a full octet, and then bromine would have to gain one electron because it's a non-metal in the seventh group to get to reach a full valence shell. So it would be C. Lithium atom lose one electron, bromine atom gains one electron. Which of the following are ionic compounds? So the first option, we're given NH4Cl. NH4 itself, it's a polyatomic ion, and it has only ammonium has NH4 has a plus charge, all from all the polyatomic ions. So it would be ionic because chlorine would gain that. It would form an ionic bonding between uh, chlorine. So it would be the first option, and then the second option, we are given two polyatomic ions, so it would form an ionic compound. But in the third option, we're only given a covalent bonding, so it's a covalent compound because it's a bond. Most hydrogen and chlorine are nonmetals, so it would form a covalent compound. So our only choice would be A. So the fifth question: write down the formula for each of the following compounds. Potassium is the first group element, and so it would lose one electron to become positive, to have a positive charge. And bromine is a seventh group element. It would gain that electron. So the positive and negative cancel each other, leaving us with KBr. And the second option, zinc oxide. Um, Zinc is a transition metal, so it would have a oxidation state. And oxygen, it's a six group element. So so it would be 2 minus, and zinc would be 2 plus because of oxygen, and it would form ZNO. And then in the C, sodium sulfate. Sodium is also a first group element, and sulfur is sixth group element. So it would be sulfate. I mean, sulfate is a polyatomic ion with a 2 minus charge, and lithium. Sodium would have a plus charge, so it would be sodium 2 and SO4 and just SO4, Na2SO4. D, copper to bromide. Copper. So we're given that copper has an oxidation state of 2, so it will be 2 plus, and then bromine, it's a 7th group element, so it would have a negative charge, -1 charge, so it would form um, uh, CuBr2 because of copper's oxidation state. And then E, chromium sulfate, chromium 3 sulfate. Chromium, we're given that chromium has, in this chemical compound, has oxidation state of 3, so it would be 3 plus, and sulfur, sulfate, it's a SO4, it's a polyatomic ion, and it has a -2 charge. So it would be Cr 2 because -2, and then um, so 4 in parentheses 3 because um, it's a polyatomic ion. You take it as a whole. You can't divide you can't give separate charges for the sulfur or oxygen and sulfate ion. So it would be Cr2SO4 3. And F, aluminum hydride. Uh, so in hydrides, hydrogen has an exception in hydrides. It forms a -1 charge, and aluminium, being the 13th or third group element, it would have a 3 plus charge. So it would be hydrogen -1 would go, so Al and H3. And sixth question, name the following compounds. Um, uh, so Sn is tin, and PO4 is phosphate ion, and it would be so phosphate. It gave its so tin became 3, phosphate became 2. Um, so as we can see, tin had 2 plus, so its oxidation is 2. Oxidation state is 2. So it would be tin 2 phosphate. And then B, it's ti- uh, Ti is titanium, and SO4 is sulfate ion. Sulfate ion would have 2 minus, and 10 would have to have 4, so so that they could cancel each other, and so 4 would be left with 2. I mean 0, and 10 would be left with titanium would be left with 2. So it would be 10 titanium 4 sulfate. And C, manganese bicarbonate. Uh, so manganese, it's a transition metal, so it would have an oxidation state, and HCO3. HCO3 bicarbonate has a minus charge, and so it would be manganese 2 bicarbonate, because um, we can see that bicarbonate has a 2 in front, so manganese would have a 2 plus oxidation state. So, and the next one, barium sulfate. Um, so, barium. Yeah, barium is in the second group, and sulfate has a 2 minus charge. So it would just be barium sulfate. There's no oxidation state. And then Hg is mercury and S is sulfur. So sulfur, um, it would be mercury 1 because sulfur has no number in front. So which means mercury has a one oxidation state. Um, and then in F, vanadium oxide. So oxygen always has 2 minus charge. The only exception is in peroxides when it's -1, and in when with fluorine it is +2 because fluorine is more electronegative. So now back to question. Oxygen 2 minus and vanadium 3 plus because oxygen has 3 in front. So which means vanadium has a 3 oxidation state. So vanadium 3 oxide. And then Cr2O3. Chromium is also transition metal. Its oxidation state would also be 3. And then and the last one, lead oxide. Um, lead would be. I need to see the. Yeah. Lead is in the it's a force group element, and oxygen has 2 minus charge. So being in the fourth group, it would need to have 4 plus, and oxygen always 2 minus. So the 4 and 2 cancel each other. So it would be it leaves us with PbO2. So and lead's oxidation state is 4, and it would be lead 4 oxide. The seventh question: what's the formula of the compound that forms from element X in group 2 and element Y in group 15? So, group 2 elements, they're metals, um, alkali earth metals. So, they always form 2 plus ions. So, we would and element Y, it's in group 15. It would have to gain 3 electrons to get its full octet. So it would be um, X2 Y. So X3 Y2. Eighth question. Explain what happens to the electron configurations of elements magnesium and bromine when they react to form the compound magnesium bromide. Magnesium is a second group element, and bromine is a seventh group element. Bromine would have a -1 charge, and magnesium would have a 2 plus charge. So cross, and then it would leave us with Mg2Br. I mean MgBr2. Um, so when the electron configuration for magnesium itself would be neon, and then so it would be 1s2. So let's do the full electron configuration for magnesium first. 1s2, 2s2, and its atomic number is 12. So it would have 12 electrons. So 1s2, 2s2, 2p6, 3s2. So So it ends with 3s2. So it would have to lose that two electrons in 3s2 orbital, s orbital, leaving us with 1s2, 2s2, 2p6. The 3s2 is cancelled, it's given to bromine. And then for bromine, it's seventh group element with atomic number of 35. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, um, 3d10, and then 4p5. 4p5. So for reaching its full octet in the fourth energy level, um, it needs to gain three more electrons. Um, so after gaining three more, 4p5, um, it would be it would gain one more. It would have one more orbital, the new one. So it would be 4p6 and 5s2. So it would have a full octet in that case. Yeah, after gaining three electrons. Um, yeah, as we can see, 12. So its electron configuration would be 3s2, neon 3s2, and for bromine it would be argon 3d10 4s2 4p5. Um, or you could just yeah. Uh, oh, I made a mistake. It was not 5s2. It was 4s2. Sorry about that. Um, yeah, as I said, it loses two electrons to become a 2 plus ion, and leaving with us with electron configuration of neon, and bromine gains um, each bromine atom gains one electron into their 4p subshell to form Br minus with the electron configuration krypton. So they form a lattice structure with an ionic compound with a formula MgBr2. So one magnesium and two bromine atoms. Two bromine atoms for each magnesium atom. So describe the bonding in ammonium nitrate. So So ammonium is NH4 plus polyatomic ion, and nitrate is NO3 minus polyatomic ion, and it would form covalent bonding between each other. No, I mean it would form an ionic bonding between each other, um, and within itself, it's actually a covalent bond, but it just has charge, and it's covalent because it does not contain any metals. So the bonding in ammonium nitrate between ammonium and nitrate, it's ionic, and within ammonium, it's covalent, and within nitrate, it's also covalent. 10th question. Which fluoride is the most ionic? It would be cesium, magnesium, and barium. It would be definitely cesium. So because as we go down uh, a group, the ionization energy decreases. Also, electronegativity. So cesium is right next, um, it's in the sixth period, and francium being the least electronegative element, and fluorine being the most electronegative element in the periodic table. So cesium would definitely form a stronger, more ionic bonding between fluorine. Um, and cesium itself is it's also really very reactive, um, and it's also present as a liquid state, similar and has a golden color. Um, and because it's so reactive, it's stored in oil, because it reacts with air and everything. So and fluorine is also quite reactive because it's very electronegative. And it's in the seventh group, so it would gain one electron, and cesium would lose that one electron. Uh, so basically, on the metals on the left side and the down side are are the least electronegative. So it would um they would lose their electrons more easily, and non-metals on the top right are the most electronegative, so they would gain electrons more easily. And yeah, that's all I can say. So, 11th question. You're given two white solids and told that only one of them is an ionic compound. Describe three tests that you could carry out to determine which is the ionic compound. So, ionic compounds, um, as in the solid state, they can't conduct electricity, but when mixed with water or melted, it does conduct electricity. So this would be our first test. The second test would be that ionic compounds have a really high melting and boiling point, because it's the strongest force between atoms. And it would also be more difficult and it would also have a higher ionic compound would also have a higher melting point and boiling point if the difference between charges would be higher. So more electrons are donated and gained, would lead to a higher melting and boiling point. So we would test the melting point. So ionic compound would have higher melting point. So solubility can also be tested. So ionic compounds usually dissolve in polar liquids like water, so it would easily dissolve in water. Um, but an example of non-polar compound is hexane. So it would not dissolve in hexane because it doesn't have a charge, so it wouldn't attract the ions and dissolve them. So, 12th question. Element E is in group 1 of the periodic table, and element G is in group 16. E and G are not the symbols for the elements. Deduce the formula of the compound formed between E and G. So E is in the group 1, so it would lose that one electron because the group number it's the number. It's also the number of valence electrons. So it would have one valence electron, and to reach its octet, it would have to lose that one electron. And element G, being in group 16, would have to gain two more electrons to get 8 electrons in its valence shell. So it would be E would have plus, G would have 2 minus. So E2G. So it would be D. And then B. Identify the nature of bonding in the compound formed between E and G. So we know that E is in group 1, so it's alkali metal, and G is in group 16, so it's a carcinogen. It's a non-metal, so it would definitely form ionic compound. It's A. C. Describe the electrical conductivity of the compound formed between E and G. A is definitely wrong. And then B. Conducts when solid. It's also wrong. Um, C. Well, our answer would be C because, as I said, when dissolved, they are able to conduct electricity, but in solid, because of its lattice structure, the electrons can't move, so they can transport the electricity and or conduct the electricity. So it would be C. Which of the following compounds would be expected to have the highest lattice enthalpy? So, the highest lattice enthalpy. So in sodium to oxygen, sodium to oxide, um, sodium has a 1 plus, and oxygen has 2 minus. And B, magnesium has 2 plus, oxygen has 2 minus, and calcium has 2 plus, oxygen has 2 minus, and then potassium has 1 plus, chlorine has 1 minus. So it would be B, because the magnitude of the lattice enthalpy increases with the product of the ionic charges of the ions and decreases with the sum of ionic radii. The magnitude of lattice enthalpy is greater for ions with larger charge density, as they have a small radius and are highly charged. Like in magnesium oxide, it's Mg2 plus and oxygen 2 minus, and they are those ions have the greatest charge density compared to the other ones. Um, and magnesium also has a smaller atomic radius, and so it would have a higher lattice enthalpy. While calcium has uh, so magnesium has 3 shells, while calcium ha- uh, calcium has 4 shells. So it has a calcium has a high bigger atomic radius. Um, and then potassium it has a um, there's less difference. So we were left in the 13th question. Which of the following has the highest lattice, highest enthalpy? Um, so I'll just zoom in. So lattice enthalpy. As I said, lattice enthalpy increases as the charge difference increases and the ionic radius gets smaller. So it would be B because magnesium. Let's take the charges first. Magnesium oxide and calcium oxide has this most magnesium has 2 plus, calcium has 2 plus, and oxygen has 2 minus. And but the others have sodium has plus, oxygen has 2, so it doesn't have a highest lattice enthalpy. And potassium and chlorine, they both have potassium has plus, chlorine has minus. So it has a low charge difference compared to calcium oxide and magnesium oxide. And then um, because we need to pay attention to the ionic radius too. So magnesium would have a smaller radius, and even smaller after losing those 2 electrons. So it would have a higher lattice enthalpy. That's the answer. So it would be B. And that's all on the questions. Thank you for watching.